Hello, welcome back. So today I'm going to discuss about multivariate linear regression using scikit-learn on red-wine dataset. So I have already imported the libraries and dataset. So the libraries we will use NumPy, Pandas, Matplotlib, and Seaborn. As you guys all know about NumPy and Pandas, Seaborn is basically used for data exploratory data analysis. So in this case, what we are going to do, we are going to clean our data. So we will do data pre-processing. We will clean our data as because the cleaning is very important, because once your data is clean, your machine learning algorithm will perform better and its performance will improve drastically. So then after that, we will make our hypothesis, and we will make our linear regression line. So in this case, this time I will be using scikit-learn to get the parameters. Last time I have used the gradient descent method. So this time I'm going to use scikit-learn and I will get the parameters of our equation. So data is uploaded. Let's go and see the first 5 values. So these are the first 5 values. So we have like 12 columns, and the last value is quality. So quality is dependent on all these factors. So this is a multivariate linear regression problem. I will select certain features and then I will tell you how to select the variables, independent variables. So we are not going to select all the variables. We will just select certain variables depending upon their correlation. So let's just check the shape of our data. So we have like almost 1599 rows and 12 columns. And the first thing we will do the cleaning part, data pre-processing. So the first part, we want to check like distribution of our plot, like how our data is basically distributed. So we'll use the Seaborn library. So checking the distribution first, distribution of our data. So it's like we'll say SNS dot displot df, and let's just check for alcohol column. So let's done this. So you can see our plot right now. So it's basically right skewed. So data is mostly skewed right. It's not a normal distribution. So the data is not distributed around the mean evenly. So it is more into right skewed, as you can see from the curve. So let's just check same thing for another column. Let's just check for density and see how it behaves. Density column. So as you can see, the density data is almost normally, basically it's a normal distribution curve. Bell curve is basically normal distribution. Most of the data is basically surrounded. Most of the data is surrounded towards mean. So it's not even a right skewed or left skewed. Now the next step is to check the missing value. So we use df data frame dot is null, and we want to count the total missing values present in each column. So as you can see, there is no missing value right now. So we are good to go. We have no missing value luckily in the data set. And then let's just check the outliers now. Checking the outliers. What are outliers? So outliers are basically the values which are far away from the mean distribution. For example, when you see this graph, if the value of like mm, standard deviation is away from the three times away from the mean value. For example, if this is the mean, center line is a mean. If the standard deviation is three times away, either in the right side or left side, we can say these values are outliers. So we don't need these outliers. So we just want our data to be normal. Uh, we want to have our data in normal distribution. So we use basically box plot or C4 library to check the outlier. So uh, let's just check for our alcohol value or any column you can use. Yeah, alcohol. So we have basically outliers. As you can see, same can be checked for density too. So density has a lot of outliers. As you can see, as all the data which is not present inside the box, they are outliers. So this is basically our range. Range is like it, uh, the data should be surrounded within the box. So now outliers certainly affects the performance of our machine learning algorithm. So what we do basically, we remove the outliers first in order to clean the data. So for the removing of outliers, we use the method of Z-score. Removing outliers. Z-score method we use. Z-score method. In stat, Z is basically your x minus mean over standard deviation. So first of all, what we will do, we will import statistics from SciPy, from scientific Python, from SciPy stats. Then what we will see, we'll check the z values, numpy dot absolute stats dot z score in data frame. So we want to check in our whole data frame the total number of values of z. So z. So now just put the threshold equal to 3. So I want to see where the values are greater than 3. So print numpy dot where z greater than 3 is greater than 3. So these are all the values in whole data set where z values are greater than 3. Let's just check for the 13 and 9 pair value. So print z 9 and 13, 13 and 9, sorry. 9. So just check. So it's a 5.3. So you can check for any pair of matrix. So you will see it would be greater than 3. Just check for 14 and 5. Let's just check for 14 and So it's a greater than 3. So let's remove it. df, we use code data frame dot inside data frame, keep all the values of z which are less than 3, keep all the values of z which are less than 3 and remove all which are greater than basic. So now just check the number of rows and columns again. df dot shape, as before you can see the total number of rows were 1599. Let's just check how much data we have removed. So see, we have basically we moved from 1599 to 1451. So basically we have removed a lot of columns because these were outliers. Now we need to select our x and y values. So data selection for x and y values, or x and y variables. That's the next step. So for this we use the correlation function. For whole data set, just use the for df.correlation, and you can see in the quality, come in the quality row, all the columns which have positive values, we will take those columns. Fixed acidity, citric acid, residual sugar, sulfates, and alcohol. We will use those columns because they are directly related to the quality. We will neglect the negative values column and we will take only the positive one. So that's how you select your features column, like your x values. So your features should be like features underscore data frame should be equal to data frame. So we will take alcohol and then residual sugar, and then we'll take citric acid, take sulfates, so we take sulfates, and then last is basically fixed acidity. So what we will do, we'll say our x is basically numpy dot as arrays features underscore df, right? Why we are saying this? Because we want to use the arrays, because numpy takes only values or data in the form of arrays or matrices. So we will use this code as arrays to convert our data into in the form of arrays. So next step is to select the y value. Our x is selected. We have chosen only 5 columns. For y, it's basically same last column, and your last column is quality. So basically data frame. So now you have selected your x and y value variables. Okay. So it's basically as array, not arrays. As array, not arrays. So now we have
problem in quality. Okay, here we need to. So now we have x and y values. Now let's just check the first 5 rows. How does our data looks like? So this is our first 5 rows and 5 columns basically. And then the next is basically appending the column of ones to make for y-intercept. So this step you guys know we did it last time too. This is called broadcasting. This is just to add add the column of ones before your X matrix, inside X matrix, just to accommodate the y-intercept term, because we need to do matrix multiplication of only parameter uh, parameter vector and our feature matrix, right? So we will use the same method like last time we did, numpy dot once m. So before this we will define our basically column and rows m and n equal to x dot shape, and then we reshape our z into column vector, right? And then we will append it this thing into our X matrix. NumPy dot append Z into X, and the axis should be equal to 1. So basically axis is equal to 1 means you are putting this thing into column, not in the row. Now, just to confirm, we will use the same technique. We will print our zeroth index row, right? Print x0 and y0, and the format we will use the same last time we did. Let's just run. So you can see now we have 1 comes before our feature matrix. The last time we have 9.4, we have 5 columns. Now we have 6 columns basically, right? So you can check the shape of your X feature feature matrix. Now you can see we have like 6 columns. Before we have 5 columns, right? And now the last thing is basically to import our Sckitlearn linear regression model. So last step is importing the model, importing linear regression model. So model is equal to Sckitlearn dot linear under regression, linear under model dot linear regression, and then we will fit the model dot fit x and y. So we will fit our model, and then Sckitlearn is dot modify. we need to import Sckitlearn. Okay, from Sckitlearn we will import Sckitlearn for linear model. Linear model, right? Okay. So now the next thing is to fit our data. So fitting is done. So we need to predict our y value. Y under predict is equal to model dot predict x. So what does it mean, the fitting of the model? So fitting of model means you are trying to learn basically the parameters. We are trying to calculate the parameters or slopes of our linear regression model, right? From linear regression equation. So y under predict is this is basically our predicted value, and we will give the value of x to get the y of predicted value y under predict. Now we will print root mean square value and mean average value. So the format should be equal to numpy dot. So y minus y under predict dot the same thing for almost means root mean square. Just we will change RMSE here. So it comes as square root. And we will also have square as well. So just run this. Okay. So we have one more. I think we have some traces there. Okay. We have to double check here. Okay, I think I got. I think I'm making a mistake here now. Yes, I got it. Okay, so that's our root mean square error and mean average error. Now just put the intercept and coefficient, printing our intercept and coefficient term. I'm just trying to be careful not to make error. Let's just run. Okay, now we get our intercept and coefficient, our parameters. So finally, so we get this intercept and coefficients. You can make our equation like this: y should be equal to 0.97917 plus 0.33. 0.33 is basically our alcohol minus 0.0475 is for residual sugar, and then you have 0.20 for our citric acid plus 1.52 for our fixed acidity, for sulfate, sorry, plus 0.03 for fixed acidity. So this is basically our final equation. We get our hypothesis. So we get the slope and intercept values. So this is basically the total our project, in which what we did, we basically cleaned our data first, and then we did data processing, we removed the outliers, and then finally we select our x independent variables using correlation method, and then we have appended the column of ones to make it for intercept term, and then finally we used scikit-learn to import the linear regression model, and then we calculated the root mean square error and mean average error, and then our parameters. So that concludes our video of the today. So I hope you guys liked it, and please subscribe to my channel and for more upcoming exciting videos.
Thank you so much and Allah Hafiz.